Hi, welcome to Nepal Digital Education. In this video series, we are going to start the numericals of the pressure. Let us look at the problem first. If a woman has weight 600 Newton and the area of her 1 foot is 50 centimeter square, what will be the pressure exerted by her on the ground? So first of all, while solving the numerical problem, we have three steps. First step, we have to write the given, and then in second step, we have to change the given into SI system, and in third step, we have to apply the formula. So let us look at the problem first. In this problem, we have woman weight, so it is force and the area of her 1 foot is area is given. What will be the pressure exerted by her on the ground? We have to find the pressure, and we know that pressure is given by force by area, and we can define pressure is the force acting per unit area. So first of all, write the given, and the given is force is given 600 Newton, and the area is given 50 cm square. What will be the pressure? We have to find the pressure. This is the given, and the second step is, first of all, we have to change the given into SI system, and force is given Newton, but area is given in cm square. So we know that 1 meter equal to 100 centimeter. We have to change here centimeter to meter. If we have to change centimeter to meter, then just dividing with 100 we get the value. So here area is given in cm square, we have to change in meter, so we are going to divide with 100. If we divide with 100, then it only change in meter, but we need here meter square, so again multiply with 100, then it is converted into meter square, so it become 0.005 meter square. This is the required area, and we know that pressure is given by force by area. So by applying the formula, pressure equal to force by area, and force is given 600 Newton and area is given 0.005. So when we calculate this 600 divided 0.005, we get 1240, and the unit of the pressure is Pascal, or we can Pascal PA, or we can also write Newton per meter square, because the unit of pressure is Pascal and Newton meter square. Pressure means force by area, and the unit of force is Newton and area is meter square. So we can also write Newton per meter square. We can also write like Newton per meter square, or we can also write PA, Pascal. These all are the unit of the pressure. So this is the required pressure exerted by her on the ground, that is 12000040. This is the required pressure, and we can also write it in scientific notation, that is 1.2 into 10 to the power 1 2 3 4 5, so it becomes 10 to the power 5 Pascal. So this is the required pressure. Let us look at the next problem, problem 2. In this problem, we have the pressure exerted by a stone on the ground is 3000 pa. So pressure is given. If the weight of the stone is given, calculate the area that stone occupies. In this problem, we have to find the area. So first of all write the given, and we have pressure. Pressure is given 3000 Pascal. Here force is given 300 Newton, and we have to find the area. So area equal to what? And we know that pressure is given by force by area. Here pressure is given 3000. Pressure is given 3000. Force is given 300. 300 and area, we have to find the area. So just by doing cross multiplication we get area. Like we have to find the area, so area equal to 300 divide 3000, because when this 3000 it is in multiplication, when it goes in next side then it comes in division. So when we divide 300 by 3000 we get area equal to 0.01, and the unit of area is meter square. This is the required answer. We can also change in cm square, like we know that 1 meter equal to 100 centimeter. If we have to change meter to centimeter, then just when we multiply with 100 then we get the answer. But here 2 meter square, so if we multiply with 200 then we get in cm square. So when we multiply it we get the value 100 cm square. So this is also answer, this is also answer. So here calculate the area that the stone occupy. So the required area is 0.01 meter square and 100 cm square. This is the required answer. Let us look at the next problem. Problem number 3. In this problem, the pressure exerted by a wooden block is 15,000 Pa. So pressure is given 15,000. If the area occupied by it on the ground is 8 meters square, calculate the force of the wood. In this problem, we have given 15,000 pressure. If the area occupied by it on the ground is given this much, calculate the force. In this problem we have to find the force. So first of all write the given. Pressure is given 15,000 Pascal, and area is given 8 meter square. Calculate the force. So we know that pressure is given by force by area. So we have P 15,000, then F, we have to find the F, and A is given 8. So just by doing cross multiplication we get F. When we multiply 15,000 into 8 then we get the value, and that is 15,000 into 8 become 1240 this much, and the unit of force is Newton. This is the required answer, but we can also write it in scientific notation, that is 1.2 into 10 to the power here 1 2 3 4 5, so it becomes 10 to the power 5 Newton. This is the required answer. Let us look at the next problem. Problem number 4. In this problem, calculate the pressure exerted by a liquid having density 13,600 and a depth of 12 meters. In this case, we have to find the pressure, calculate the pressure. In this problem, we have to find the pressure exerted by a liquid having a density. Density is given and depth is given. And we know that when we have to find the pressure in case of depth, then we have P equal to H dg. We use the formula P equal to H dg when the case of height or depth. So first of all, write the given. Given is density is given 13600 kg per meter cube, and depth means height, no, height is given 12 meter, and we have to find the pressure. Here calculate the pressure, we have to find the pressure, and pressure is given by HdG, and height is given 12, and density is given 13,600, and we know that the value of G is 10, or we can also use 9.8. G equal to 9.8 meter per square second, or we can also use G equal to 10 meter per square second. So when we multiply 12 into 13600 into 10, when we multiply this number, then we get 1.632 into 10 to the power 6, and the unit of pressure is Pascal, or we can also write Newton per meter square. This is the required pressure. Calculate the pressure exerted by the liquid having density this much and depth is 12 meter. So in this problem the pressure is 1.632 into 10 to the power 6 Pascal. Let us look at the next problem, problem 5. In this problem, how much pressure exerted? So in this problem also we have to find the pressure. We have to find the pressure exerted by the bottom of the well if the depth of the well, in case of depth and height we use P equal to H dg. In case of depth or height we use pressure equal to H dg, height, density and acceleration due to gravity. Here P means pressure, H is pressure, H is height, or we can say depth, height or depth. D is density of liquid, density, and G is acceleration due to gravity, So in case of depth we use this formula P equal to H dg. So how much pressure? So in this problem we have to find the pressure exerted by the bottom of the well if the depth of the well, depth means height, is given 6 meter. How much pressure exerted by the bottom of the well? In well there is water, so we know that density of water is 1000 kg per meter cube, because the unit of density is kg per meter cube liquid. So density become 1000, and we know that pressure equal to H dg in case of height. So height is 6, density is 1000, and G is, and we can use here G 10 9.8 also. Yes, if we use 10 then it becomes 6 1 2 3 4 0, and the unit of pressure is Pascal, PA, or we can also write Newton per meter square. So this is the required pressure. Let us look at the next problem, problem number 6. In this problem The pressure is exerted by the liquid on the bottom of the container of height. So height is given, pressure is given. Find out the density. We have to find the density. In case of height, we use P equal to h dg. So first of all, write the given height is given 3 meter, 3 meter. This is 3 meter, and pressure is given. Height is given 3 meter and pressure is given 4500 Pascal. Find out the density. We have to find the density. So we know that in case of height, pressure is given by P equal to h dg. P equal to h dg. So pressure is given 4500, height is given 3. We have to find the density. Here g means acceleration due to gravity. We can use here 9.8 and 10 also. If we use 10, it becomes easy to solve the problem. 4500, 3 into 10, it becomes 30 into d, and we have to find the d. So 4500, it is in multiplication. When this 30 come this side, then it becomes it comes in division, and we have to find the d. So when we calculate this 4500 divide 30, then we get the value. Let's calculate it. We get 150. So we get our value 150 equal to d. Therefore d is 150, and we know that the unit of the density is kg per meter cube. If you forward the density, then we know that density is given by mass by volume, and the unit of the mass is kg and volume means meter cube. So meter cube, meter cube. So in this way we get the unit of the density, that is 150 kg per meter cube. So this is the required density, that is 150 kg per meter cube. Let us look at the next